going to talk about carbohydrates and really try to understand the carbohydrate family, okay? And the reason why I call it a carbohydrate family is because all the carbohydrates, they all are considered just sugar molecules. So if you think of carbohydrates, just think of sugar, okay? They're sugar molecules. But carbohydrates can be classified as monosaccharides, some are disaccharides, and some carbohydrates are polysaccharides. Now, what's the difference? Monosaccharides are just single molecules. They're single molecules, single sugar molecules, okay? They're basically, think of it as the smallest sugar molecules that exist, okay? One example is glucose, all right? And glucose looks something like this. All right, and then I'm missing a bunch of OHs, but you get the picture. It's just a single molecule of sugar, okay? Glucose is an example, and we'll talk about other examples later on. Disaccharides is when you take two monosaccharides, two single sugar molecules, and you link them together. So for example, if we took two glucose molecules, right, and we linked them, that's what you call a disaccharide, when you take two monosaccharides and you link them together, all right? And so there's lots of different examples of disaccharides, but the key idea is a monosaccharide is a single molecule, a single sugar molecule, and funny enough, saccharide means sugar, okay? So single sugar molecule. Disaccharide is a molecule that's made up of two sugar molecules or two monosaccharides, right? And finally, a polysaccharide is when you link hundreds to even thousands of monosaccharides together. So 100 to 1,000, okay, sugar molecules connected together. All right? And so that is the difference. So you guys got to remember that the carbohydrates, all right, okay, the smallest carbohydrates are called monosaccharides. When you link two monosaccharides together, we get a disaccharide. And when you have hundreds to thousands of different monosaccharides connected together, we call those poly. Poly means many sugars in one chain, okay? And some examples include starch, cellulose, glycogen, all right? And most polysaccharides are actually built by plants because that's how they store their energy, by building these huge, massive polysaccharides, okay? So we're gonna have a later on discussion about monosaccharides and disaccharides more in depth, but remember, carbohydrates are sugar molecules. There are some that are very small called monosaccharides. When you link two monosaccharides together, you get a disaccharide. And when you have thousands, hundreds of monosaccharides connected together, you get a polysaccharide. So hope this helps. Okay, now we'll move on to our next topic. All right, guys, now let's talk about monosaccharides and in more detail. So what we have here is 1, 2, 3, 4 different monosaccharides. And if you remember from our last discussion, mono means one, saccharide means sugar. So these are single sugar molecules, okay? Now, this molecule is super special. Okay, you've actually built it hopefully in class already. It is called glucose, all right? This molecule here is called fructose. This molecule, which actually looks a lot like glucose, but it's not, it's called galactose. And the final one, okay, this one is called ribose. Okay, and these are not the only monosaccharides that exist. There are more, but these are just 4 examples that I want to use to explain to you what a monosaccharide is. As you can see, you should notice there's actually something in common with respect to their names. if you are dealing with a carbohydrate, their name is always going to end in OSE. So the name always gives it away, all right, that it's a carbohydrate. So glucose, fructose, galactose, ribose, deoxyribose. Okay, the last three letters there, if they're OSE, then you know you're dealing with a carbohydrate. Now, glucose is a monosaccharide because it's a single sugar molecule. And now let's talk about its formula. Remember, the corners are carbons, right? So 1, 2, 3, 4, 5, 6. It has 6 carbons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. Okay, and oxygens, 1, 2, 3, 4, 5, 6 oxygens, all right? So that is the formula for glucose, all right? Now let's talk about fructose. Let's start with the carbons. Carbons, 1, 2, 3, 4, 5, 6. Whoa, 6 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoa, 12 hydrogen and oxygen. 1, 2, 3, 4, 5, 6. Whoa, 6 oxygen. Now notice, they have the same formula, but the structure is different. Okay, so sometimes you will get that. All right, so just because the formula is the same doesn't mean it's the same molecule every time. So the structure matters. And galactose, I'm just going to give you a hint, since it has 1, 2, 3, 4, 5, 6 carbons, then it's going to have 12 hydrogens and 6 oxygens. Okay? And ribose. Now let's take a look at ribose. Ribose has 1, 2, 3, 4, 5 carbons. Okay, hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. 1, 2, 3, 4, 5. 5 oxygens. And so notice there's a pattern here with the formulas. Okay, so number one, let's take a look at the atoms that make up carbohydrates. Notice all these carbohydrates, all these monosaccharides only have carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. So if you see a molecule and it has nitrogen, then you know it's not a carbohydrate. All carbohydrates are only going to have carbon, hydrogen, and oxygen, all right? So that's very important. Now notice all of these carbohydrates, all carbohydrates are going to have this, okay? What do you notice here? They all are going to have a ring structure. So all carbohydrates will have a ring structure as well. So not only will it have carbon, hydrogen, oxygen, but it also is going to have a ring, right? The ring here for glucose, it's a hexagon because it has 6 sides, 1, 2, 3, 4, 5, 6. This one is a pentagon. Another hexagon. And 1, 2, 3, 4, 5. 5, this is another pentagon. See that? So all carbohydrates only are going to have carbon, hydrogen, and oxygen, and they're all going to have a ring. All right, so that's very important. So when you're trying to identify or determine if it's a carbohydrate or not, okay, these are the first 2 criteria. Okay? Now let's take a look at some molecules to kind of test your knowledge. So here's a molecule. It has a ring. Is it a carbohydrate? Pause the video. Think about it for a little bit. Now, if you did already and you're paying attention, this right here is not a carbohydrate because it has nitrogen. And remember, we said carbohydrates only have carbon, hydrogen, and oxygen. So this right here, nope, it's not a carbohydrate. How about this guy? Is this guy a carbohydrate? Think about it. Pause the video. Think about it for a little bit. Now, does it have a ring? Yes. Does it have carbon? Yes. Does it have hydrogen? Yes. But what's it missing? It has no oxygen. So, this is not a carbohydrate. Okay? Now, final example. Is this a carbohydrate? Now, it has carbon, it has hydrogen, it has oxygen, and it has a ring. Now, then, is it a carbohydrate? The answer is no. Why isn't it a carbohydrate? Even though it has a ring and it has all the 3 atoms that we're talking about. Well, one thing that we haven't talked about is notice, okay, in glucose, there are 6 carbons and there's 6 oxygens. They're the same, right? And there's twice as much hydrogen than there is carbon. Same thing here. Look at, if there's 6 carbons, there are 6 oxygens and twice the amount of hydrogen. Same here, same here, same here. Now, here you have 5 carbons, 5 oxygens. Notice it's the same. The ratio is the same. If you have 5, you have to have 5 oxygen and twice as many hydrogen. So the final criteria is number 3. There has to be a 1-to-1 ratio of carbon, hydrogen, and oxygen. So, for example, let's say we had a carbohydrate and it had 7 carbons. Well, if it's a carbohydrate, then it should have 14 hydrogens. And it should also have 7 oxygens, because then we have the ratio there, right? If we had a carbohydrate that had 10 carbons, then if it was a carbohydrate, it would definitely need to have 20 hydrogens and 10 oxygens. See? The same amount of carbon and oxygen and twice as much hydrogen. All right? And so if you take a look at this molecule, it's not a carbohydrate because it has 6 carbons. So it should have 6 oxygens. Also, it has 6 hydrogens. Because it has 6 carbons, it should also have 12 hydrogen. So when you're identifying and trying to figure out the difference between molecules, carbohydrates, okay, the rules are only can have carbon, hydrogen, and oxygen, or CHO, must have a ring, and it has to have this ratio of atoms. And that's why they're actually called carbo. If we put the 2 right here, what do you notice? Carbohydrate, carbon with water. And guess who or what living organisms make all our carbohydrates in the world? Think about it. Who needs carbon? Who needs water? All right? Tell me the answer in class. See you next time.